Alright, tonight's video is going over how scientists learn about the interior of the Earth. So in this next unit, plate tectonics, we're going to be looking at the inside structure of the Earth as well as how the surface features of the Earth change. But before we can learn what's inside the Earth, we have to learn about how scientists have been able to figure this out. Because the Earth is a pretty big place, but we actually know with surprising detail what the inside of our planet is like. So we'll talk about the two ways that scientists learn about the interior of the Earth. Right, and this is, we're now in your Earth structure book. That's the one with the rock on the cover, and section 1.2, pages 10 and 11. So, first thing we do is how do we explore the interior of the Earth? And there are two types of evidence that geologists use to learn about the Earth's interior. So we have two types of evidence. The first is direct evidence, meaning we have that evidence in our hands from rock samples. So we can drill up rocks from inside the Earth, see what kind of rocks there are, see what the composition of the Earth is like. And then we have what's called indirect evidence from these things called seismic waves, which you may have heard about already, and if not, you'll learn about them in a few minutes. So first, let's look at the direct evidence. All right, this is pretty straightforward and pretty logical. Evidence from rock samples. And so scientists use cores of rock drilled out of the Earth to learn about rocks deep underground. So with a drill, you can have a hollow drill bit, and so as the drill goes down into the Earth, it surrounds a small little tube of rock, maybe 2 or 3 inches around, and then when you pull the drill back up, you can bring that rock with it, and so you get this long core of rock, and so it looks kind of like this. This has been split up so that it'll fit in a case to carry, but that way you can learn what the rocks are like underground. Problem is, even the deepest hole we've ever drilled into the Earth is only 12 kilometers deep. And the Earth, the distance from the surface to the very center is about 8,000 kilometers. So to go any deeper than that requires technology that we don't really have or would be extremely expensive. The temperature gets really high, your drill starts to melt out from under you, and so it's not really worth it to try and drill deeper than that. So we turn to our other type of evidence, which is evidence from seismic waves. And so a seismic wave is a vibration that's produced when an earthquake happens. So if you were to bang on the table where you are, I don't recommend you do this without telling everybody else at the table what you're doing so your mom doesn't freak out. But if you were to smash that table, bang on it hard, you'll feel the vibrations move through the table. When an earthquake happens, vibrations are sent through the Earth in much the same way. We call them seismic waves. And they travel not only along the Earth's surface, but down straight through the Earth, right? So towards the other side. And it turns out that they travel at different speeds depending on what the material they're traveling through is. So if they go from one type of rock to another, they change speeds and they actually bend a little bit. And so by measuring the arrival of seismic waves at different points around the Earth, we can compare that data to tests from a lab to figure out what the inside of the Earth is like. And so here's kind of a map to show this. Say this is a cutaway of the Earth, so the very outside is the surface, and this is as if we have sliced the Earth in half. Right? And so if an earthquake happens at one point, say this is California, not only do those seismic waves travel away from the earthquake, but they also go straight through the planet. Right? And they'll actually reach almost the entire other side of the planet. Right? At this point, they're too weak for humans to feel, but we can still record them with a seismograph. And we'll talk about these shadow zones later on next week when we talk about, or when we get to our earthquake units and we talk about the different types of seismic waves. But you can see as these waves go, as they cross from one type of earth layer to the other, as they go from this layer, which is called the mantle, to the outer core, they bend. And when they come back, they bend again. And so by kind of mapping and seeing how long these waves take to get there and seeing where they arrive, we get a pretty good picture and a pretty good understanding of the inside of the Earth, which is pretty cool considering we've gone less than the distance of this little tiny line around the Earth inside, but we have a pretty good understanding of what the inside is like. So make sure you put your 3 questions at the end, and I will see you in class for a short class tomorrow after our delayed opening.